Question number 2A in the free response section says Stephen swims back and forth in a straight path on a 50-meter long pool for 90 seconds, and the velocity is measured by this v of t function. Now remember, velocity has direction, so if it's going to the right, it's going to be positive, left, it's going to be negative. And it says where t is measured in seconds and v is measured in meters per second. Part A asks, find all the times t in the interval 0 to 90 at which Stephen changes directions. So that means that he's going from positive to negative or negative to positive, and then give reason for your answer. So the first thing we're going to do is we're going to input this function into the calculator and graph it. And when you adjust your windows, you should get a graph that looks something like this. And we're trying to find, we first of all want to recognize that this is a velocity function. So we want to find where v of t is equal to 0. So where this v function crosses the x-axis. So we're going to use the 0 function on the calculator. And using the 0 function on the calculator, we're going to calculate that value at that green dot, and that works out to be v of t equals 0 at t equals 56 seconds. Okay, so that's where it changes direction. We probably should do some sign analysis here. We have 56 seconds. Our v of t is equal to 0 at that point. It's also equal to 0 at t equals 0. However, when we take a look at the velocities, it is positive up here on this side, negative on this side, and there's no change of velocity at the starting point 0, but there is a change of direction of velocity across 56 seconds. Okay, so the answer then is going to be at 56 seconds. And we can see that on our slope chart is changing from positive to negative at that point. For part B of the problem, the question says, find Stephen's acceleration at t equals 60 seconds. And then show the set of calculation to indicate units of measure. So the first part here is we need to recognize that acceleration is the derivative of velocity. So we need to find the derivative of this velocity function. And since this is a graphing calculator function, we're going to use the dy by dx function on the calculator to find slope. So what we're going to end up doing then is we will find the slope at 60 seconds. So that green dot is at 60 seconds, and where that slope line represents the slope at 60 seconds, or in other words, the acceleration. So using that slope function, a of 60, okay, when we use the dy by dx at x equals 60, we end up with a slope of negative 0.0360102. Okay, so about 0.036. And this is going to be in meters per second squared. And again, it does say indicates the units of measure, since the velocity is in meters per second, the slope will be in meters per second squared. The second part of this question asks, is Stephen speeding up or slowing down at time equals t seconds? T equals 60 seconds, and give reasons for your answer. Well, to know if something's speeding up or slowing down, first of all, we have to remember that velocity and speed are different. Okay, so to analyze speeding up and slowing down, you have to consider the direction of the sign of the velocity and the direction or the sign of acceleration. So that's important. And we need to consider how they are relative to each other. So if velocity and acceleration are both positive or both negative, what's happening is the acceleration is working with the velocity, and that means it's going to speed up. If we have velocity and acceleration are opposites, so positive velocity and negative acceleration, or negative velocity and positive acceleration, the acceleration velocity is working against each other, therefore slowing down. So looking at the acceleration, well, we had the a of 60 was negative, and looking at our v function, the y coordinate of v, although we could probably, it looks like it's maybe negative 0.06, it really doesn't matter whether it is what the value is. We just know that v at 60 is going to be negative. So we have velocity and acceleration are both negative. That means they're working with each other. So since they're both positive, since v and a are both positive, or sorry, both negative, it is speeding up. Okay, so v and a are both negative, it is speeding up. Now, one last note about this problem is that there is another strategy, but it's much harder. We could differentiate to get the acceleration here. So the derivative I've written down here, but again, this is a much harder strategy. This is unnecessary because this is a graphing calculator problem.